Okay, so welcome back. Now, we're going to do another example, but notice that now it's got the inverse function on the inside. Okay, the last example, I showed you how to deal with where we have the inverse function on the outside, okay, and we have the trig function on the inside, okay. Now, what I'm going to do is I'm going to do this example, and I'm going to show you the direct way, and this works. You can use the Pythagorean theorem, or the Pythagorean identity. I'm going to show you both ways, and you get the exact same answer. And to me, one way is easier than the other. And again, just watch. Okay, so I'm going to reason a couple of different ways. So the first way I'm going to do it is I'm just going to deal with the inside. I'm going to kind of reason through and explain to you how I'm thinking. Okay, so let's do our right triangle. And so let's say we have this right triangle, and the first thing I'm going to do is, this is the cosine inverse of the ratio 4/5, right? So what this is saying is, remember, this is an angle, right? This is an angle. So I'm asking myself, okay, the cosine of what angle equals 4/5, right? So let's say I've got this angle, and I've got this right triangle, right? And I know that the ratio is going to be what? The cosine of what angle, right? So I don't know what this angle is, but I know that the cosine of this angle is 4/5, okay? Because that's what this is telling me. This inverse cosine represents an angle such that the cosine of that angle is 4/5. So I know that based on that 4/5, remember, definition of cosine is adjacent over hypotenuse. So I know this and this must be true, right? So what else needs to be true? Well, now what I can do is, now that I know this is theta, right? So this whole thing is theta, but I don't know what theta is, okay? All I need is the triangle. So, in other words, I can use the Pythagorean theorem and find that this side is 3. Right? And furthermore, keep in mind that this is, the restricted domain is on this. So the restricted domain is going to be 0 to pi. Okay? So again, we want, it's from 0 to pi. Oops. Okay. So that means we're in the first and second quadrant, right? So now you can use the Pythagorean theorem, right? Because a squared plus b squared equals c squared to get this value, right? So this is going to be just so you can see that it works. Because this is a special triangle, it's a 3, 4, 5 triangle. So as soon as you know that this is 5 and one of the sides is 4, this has to be 3. And so I'll show you. So we know that 4 plus x squared equals, 4 squared plus x squared equals 5 squared, right? And so this means that 16 plus x squared equals 25, right? And so that means if I subtract 16 from both sides, I get x squared equals 9. So x equals plus or minus 3. Now, the reason why I put positive 3 is easy. My angle, right, has to be between 0 and pi. And I know that the cosine of that angle is 4/5, and it's positive, right? So cosine of this angle is giving me a positive number. And so cosine is positive in the first and fourth quadrant. Okay, so that tells me that I'm in the first quadrant. Okay, and so therefore it has to be positive. And so now guess what? I don't even need to know what this angle is. I do not even know what to figure this out. All I needed to find was this triangle, and now the sine of theta is what? Opposite over hypotenuse. So sine of theta equals 3/5. And I'm done. Okay, now that's one way of doing it. The other way of doing it is I can use the Pythagorean identity. Right? So I know that the cosine of theta equals 4/5. Right? That's what this is telling me. On this here, cosine of theta of this angle, whatever this angle is, right? The cosine of theta equals 4/5. So I can use the Pythagorean identity that says sine squared theta plus cosine squared theta equals 1. So that means sine squared theta plus 4/5 squared equals 1, which says sine squared theta plus 16/25 equals 1. And then now I'm going to subtract 16/25 from each side. And so I get sine squared theta equals 1 minus 16/25, which is equal to what? Well, this is going to be 9/25. And now if I take the square root of both sides, I get sine theta equals plus or minus 3/5. And again, it can't be negative because I'm in the first quadrant, because cosine is giving me a positive value, and cosine is only positive in the first and fourth quadrant. Okay? And so therefore, again, I get the same answer. Okay? Have a great day.